that. Someday I'm going to remember to do that. One of my other classes, I always have this one person is like, don't forget to record. Okay. That sucks. All that beautiful shit just gone. All right. Yeah, if you're watching this video in the future, there was about a good 15 minutes that wasn't captured. Sorry. So last time we got up to this point, okay, so this is the first step of a hypothesis test, which makes sense. The first step in any statistical analysis is, what is the claim? And then you set up kind of the two opposing viewpoints. So let me see who remembers this. If my claim was mu equal 11, where would I put that? In the first spot or the second spot? In the HO or the H1? Hi. It's not right. What's got to go in the HO? What's got to go here is the one that has an equal sign. If it has an equal sign, it must go here. And the reason we set it up that way is we just want the statement that goes here to be the one that we can show evidence for. And again, I cannot take a sample from a population and show evidence that the mean equals something, because nobody that did this T-score practice sheet got the exact mean. Of course not. That would be so unlikely that you pick 20 from a group of almost 200, whatever it was, and get the exact mean for all of them. That's more than likely any sample is going to have a mean very different from the real mean, right? So I cannot take a sample and show evidence that the mean equals something. But I can show evidence. What's the opposite of mu equal 11? What's the opposite? And you can just write words if you can't, because the symbol you can't do, I don't think, in the text box. Yeah. So mu not equal to 11. I like it. So somebody's like, I think that I could throw the stone 11 feet, exactly 11 feet. And I like it, Livia, you're right. That used to be the symbol we used. They kind of replaced it with not equal to. Now go with me. So somebody's like, I could throw this exactly 11 feet. This is a good example. If they threw it 10.9 feet, isn't that still impressive? Do you guys see what I'm saying? Anybody maybe? But if they throw it like 9 feet, screw them. Nah, dude, nah. You said you could do 11, right? Maybe. So if somebody's like, I can throw it 11 feet, what would show that they're wrong? How many tail tests would this be? If they say I can throw it exactly 11 feet, how could we disprove them? How could we show evidence that they're wrong? How can I show evidence that this statement is right? Either they throw it several times and it's 2. I'm not sure what that means. Oh, I see, 2 tails. Okay. To show evidence that this is wrong, I could either get like he throws several and it comes out to 15 feet, or he throws several and it comes out to 9 feet, right? So this would be a 2-tailed test, because not equal to means down or up. So that's why the T-score chart is set up the way it is. It's these could be 1-tail tests if it was greater than 11 or less than 11, or they could be 2-tail tests. And that's why the T-score chart's got both options up at the top. I like it. So that's the first step. What's the claim? What are the hypotheses? And how many tail tests will it be? So these are the first two steps we did last time. Second step would be, can I use Z or T or nothing? Make it H. And of course, here I would check, is N greater than 30, or does it say it's normal? And then do I know sigma or only S? Right. Okay, so let's do this. The other steps kind of flow really well. So I'm gonna transition over. Let me see if I can pull this thing up here. Oh, so much shit going on. Let me see, let me get rid of you, get rid of you. Let me see, got rid of too many things. Hold on. Bum, bum, bum. Maybe I can pull it up here, yeah. Oh, the hills are alive. Let me see, where'd I put that? There it is. Bear with me. And you're all like, that's all we ever do. There we go. Okay, got it. Where are you? There you are. Okay. Bam. Okay, now you should be able to, that's not the right thing, is it? No, I don't want that one. That's too early for that, Jeff. I want this one. There we go, buddy. Can somebody tell me what's the first problem about? Just type it in there real quick. What's the first problem about? Is it about cars or is it about animals? Just help me out. I just want to make sure you see the right thing on your screen. Is the first one about cars or animals? Good, thank you, coyotes. That's the right thing. Because on my screens, I can't tell which one you can see right now, to be honest. Okay. So read through this real quick. Just read through. Come on in. There. Read through this. Just read through it. So this first problem, I want you to realize I was really nice. See how much bolding I did? Trying to really make sure you see what parts are most important. So somebody help me out. This kind of sucks, but oh well, too bad for me. What's the claim gonna be? And you can see the language goes right along with what you think it would be. Who's making a claim here? And what is that claim? You can say it if you want to, too. You can unmute yourself, or you can just type it. Or you can continue sleeping because you logged in and went back to sleep.
Is the claim that all coyotes in captivity, their lifespan is 10.15 years?
No.
No, it's the one where it's 12.45.
No. So the claim, all right.
Uh-huh.
I know that the lifespan of all coyotes is 10.15 years. I'm not going to make a claim that about all coyotes being 10.15. So here it is. You ready? Look at the first sentence. What's the magic word in the first sentence that tells me that's a claim?
Live longer?
No. Believes. A researcher believes that the northern Minnesota coyote lives longer in captivity if they're given more room to roam. So how long does a coyote live normally in captivity, period? 10.15 years. So what's his claim then in mathish? He thinks the mean is longer if they're given more room to roam. So he thinks the mean is how related to 10.15. So all coyotes live 10.15 years in captivity. Are you guys with me? It says that, right? And I can't remember if I actually looked this up or not. I think I did to get a rough idea. He thinks, yes, where am I at, Olivia? He thinks that if they're given more room to roam, the mean will be greater than normal. So greater than 10.15. Which, now real quick, I want you to stay with me, which number would never show up in the first step? 12.45. That came from the sample, and I do that later, not till step 4. Do we do anything about a sample? So stay with me, stay with me. So Phil thinks they live longer. If they get more room to roam, they normally live 10.15 years. Therefore, bear with me with this shit. This is gonna be bad. Oh well. The mean, maybe I zoom in. You can do it, Jeff. The mean, the claim is the mean is greater than 10.15 years. Okay, could have been so much worse. I actually ordered like a pen, a mouse pen. Supposed to get here tomorrow, so I'm hoping that'll help me with this kind of stuff. Can you guys roughly, approximately read that? Let me let you guys catch up. Make sure you can that makes sense. Why are you not going anywhere now? What's going on here? There we go. Anybody have trouble with that very first thing? Can you guys see that? I mean, obviously, if you get the claim wrong, that's going to mess your whole problem up because that's where things start. So who thinks something and what do they think? So you can write it in English and then you can write it in Mathish. So where's that going to go? Is it going to go in for the ho or the high? Yes, I don't see an equal sign here, right? Oh shit, here we go again. So I'm going to put mu greater than 10.15. Oh my God, I feel like I'm 4. Okay. Right? So what goes in for the other one? These are the 2 old men in the coffee shop. They both disagree automatically with each other. Yes. The opposite of greater than is less than or equal to. All right, that's insane how long that takes me to do. Oh, well. Too bad for everybody. Now watch. Now let me reinforce this idea. Let me stop for a minute. Please let me know if you're having any issues with what we've written so far. It really is write the claim in English, then translate it to Mathish, mu greater than 10.15. Then you just forget about what the claim was. You say, is the thing I just wrote down, does it have an equal sign? You put it in HO if it does. If it doesn't, you put it in H1. And then the other one is the opposite. Okay. Oh, let me see. I can't. Yes, okay. All right, I don't see anybody with any issues, or you have too many issues to start. I don't know. So how many tail tests will this be? Which, can you claim the claim? So a researcher believes that the coyote lives longer if given more room to roam. Lives longer than what? What do they normally live? Mean lifespan of all coyotes in captivity, oh, they normally live to be 10.15 years old. So therefore, this guy or girl believes that the mean is greater than 10.15. Can you guys see that? So they're not going to just say, hey, the claim is mu less than 3. No, you got to actually read through and piece it together for yourself. Does that make sense? I mean, you're going to have to do that. You're just going to have to take a minute, read through it. Who thinks something and what do they think? Can you write in math what it is that they think? The minute you write that, you write the claim, then you say, well, where does it go? Which spot does it go in? This is the one that I can show evidence for because it's the one that doesn't have an equal sign. You see, that's why we set it up the way we do. I can show evidence for different. I can't show evidence for equal. Okay. So looking at this, you always look at this guy. He's the one. I don't care what my claim is anymore. I don't care what my claim is anymore. It gets me started. And then at the end, I've got to say how the claim came out. Can somebody tell me how many tail tests will this be? How would I show evidence of greater than something? Where would my sample have to show up? Could it be on either side of it? So it's 2 tails? So if I assume that 10.15 is right here, you can do it, Jeff. I see somebody wrote something. I can't see it yet. Hold on. Oh, crap. Pretend like that says 10.15. Yes. If this guy thinks it's greater than 10.15, the sample has to show up way over here. It has to show evidence of that. Do you guys see that? The H1 says greater than 10.15. The only way to show evidence is to be above 10.15. So how many tail test is this? One. You can see it. There's the one tail. So that's why I was trying to tell you, when we're making confidence intervals, they're always two tails. They're always two tails because that's the process. You chop off the middle, you make two tails. And then I told you this next chapter is going to explain why the T-score chart has 1 and 2. Here we go. There's a one-tail test. So I'm going to want to look at that row on the T-score chart. We'll get there in a minute. All right. So that's the first step. Oh, great. And there's 5 steps. Yay. So next step. Can we use Z-scores, T-scores, or nothing? So what 2 things do you need to look for? First one is most important. Is it normal? Oh, man. Up. Okay, that's exciting. Can anyone see why it might be normal? Do I say it's normal?
No.
Shit.
But you do have the sample of 41, which means n
Yeah.
greater than 30.
N greater than 30. Chicken, lettuce, tomato says, great. I like it. I guess this is okay for like a amateur graffiti artist. I don't know what that is, but hopefully you guys can read that. And then the second thing, so that tells me I could do something. If it wasn't normal, I can't do shit in stats 1. And that's where we all are. It is normal, thank God. What's the second thing I look for to determine? So I know it's not nothing. I know I can do something. That's the number 2. What is it that I look for to see? Yes. Which standard deviation do we know? And again, I was really nice. Not only did I bold,
population standard deviation.
yeah, I know the population standard deviation. So what's that mean I can use? Holy crap, sigma is known. Somebody else, what could I use then, since I know the population standard deviation? Which one? Do I use Z or T? You could do it. Why were T-scores invented? Because somebody got really drunk on Guinness. No. They were invented for when I don't know the population standard deviation. I do know the population standard deviation. So do I have to use T-scores? Nope. I am allowed to use, pretend that says Z. That's like drunk Zorro. What the shit? Oh, well. Let me stop right there. So that hasn't changed. We've known that since chapter, what the hell was it? Well, all the way since chapter 8, section 18. T-scores were invented for when I don't know the population standard deviation. So if I do know it, I don't use T-scores. They don't come into play. It's not their job. All right, so the first 2 steps, this is new, but it's not difficult really. It's who's got a claim, what is it, where does it go, what's the other one? So it takes a little practice, but it's not that bad. Part B is old news. Part B is old news. We've been doing that kind of shit for a while. Part C is new. Okay. So remind me, this is a one-tail test, and the tail is going to be up here because that's greater than right there. So if you need it, H1, whatever direction the arrow is where the tail is. So it's only going to be 2 tail if that was not equal to. All right, so I know it's a one-tail test. It's up here. What's the area that's in that tail? Become an arrow. Oh my God. All right. Can anybody tell me what the area in that tail is if you read part C? Yeah. Remember this little dude here? Little fish dude? The little alpha dude? That's the area in the tail or tails. By the way, something about this handout. This is a really good handout to have sitting next to you when you do these problems. I need to say this a few times. The book references a dumbass worksheet in the back of itself to use for these problems. Screw that worksheet. Screw it. Use these 5 steps. They do the same 5 steps. They just do it out of order because they let the calculator do all the work. And unfortunately, you have a teacher that wants you to do the work. I know, it's crazy. So use these 5 steps. And do you notice what I'm trying to do here with these little notes? In black, it's kind of like the practical side. And in red, I think I try to make it more conceptual. I can't remember what the purpose was. This step tells us how far away our sample has to get. So the whole idea, remember the whole idea of hypothesis tests was if like the dude said he could throw a stone on average 11 feet away. And we're like, I don't think so, man. You're going to be. As long as he's close to 11, I'll say that's evidence your claim is okay. I can't say your claim is wrong. It's not enough evidence to say your claim is wrong. So what I'm doing in this step is I'm showing how far away does my sample have to get to show evidence that it's different. So this is where the null thinks things are, right? The null has the possibility of equal, right? So how do I show the null is wrong? Well, I get way out here. If I get way out here, that's evidence that this is not right because it would be so unlikely to get out here. So really here, you ready? Here we go. So a hypothesis test boils down to 2 things. What's far enough away to show evidence? And then how far away did my sample get? So the most important steps in this test is part C. Part C sets up a benchmark. You've got to get this far away. And then part D is going to be where we actually see where the sample goes. Was it far enough away or not? Oh, okay, here we go. So alpha is 0.01. I know it's a one-tail test. You could have just put the number 1, John. I know. So one-tail test, alpha 0.01, and I can use z-scores. I don't know if I made a big deal out of this or not. I think I did a little bit. Remember at the bottom of the t-score chart are z-scores, right? Like that one definitely looks very familiar, 1.645. At the bottom of the t-score chart, there are z-scores. So if I need a z-score for a hypothesis test, damn straight I'm going to use the t-score chart. And I always get a student that's like, why are we looking at the t-score chart if I want a z-score? Because they're at the bottom. So basically with this chart, if I stop somewhere, I get a t-score. If I go all the way to the bottom, I get a z-score. Now, why does that kick? I just know I've lost like at least half of you guys, so stay with me. Some of you guys, you never had me, dude. I'm in bed sleeping. Oh, shit. All right. So look at the top. I've got a one-tail test. And alpha's 0.01. So I'm going to look at that first. Where am I at? One-tail test. One-tail test, Jeff. You can do it. There it is. 0.01. Do you guys see that? It's not easy to do. One-tail test. 0.01. And if I go all the way to the bottom, I'll get the z-score I want. So this sounds like a note. If you stop on the t-score chart, if you stop, where's my hand? If you stop somewhere, you get a t-score. If you go all the way to the bottom, you'll get a z-score. So that's the z-score I want, 2.326. So this will be 2.3. Oh my God. All right, that one I have to redo. Go away. 3, 2, 6. Okay. So now think about it for just a second. Back in the day, when we first started laying the groundwork, Where did unusual start? Where did unusual start? How far away from the mean did unusual start? We know this. How many steps did it have to take to get to unusual? How many
Two
ellipses?
standard deviations.
How many, sorry?
2 standard
2.
deviations.
I like it. So in this problem, so chapter 9 is where we can change the definition of unusual based on the situation. So in this problem, they've determined alpha needs to be 0.01. So how far away until my sample is unusual enough to say it doesn't look like that's right? 2.326 steps. So if, oh crap, this is a lot of words. Here we go. If my Z star, oh shit, what does Z star mean? We'll talk about it in a minute. If the Z score I calculate from my sample is more than 2.326, right? And that's only got a 1%, that's got a 1% chance of happening. So I really, no, stay with me. If that is the right place for the mean, if the mean really is 10.15, then a sample should only occur up here 1% of the time. So if we go take a sample and it shows up here, it is more likely that the mean is wrong. That is evidence that the mean is wrong. Is it proof? No, there's a 1% chance that it would show up there no matter what. But it is evidence that it's wrong. So it's sort of like, you know, when we flip a coin, if you flipped a coin 500 times and you got 480 heads, wouldn't you say that's evidence that something's been done to that coin? Because if you flip a coin 500 times, how many heads do you expect? What's the average number of heads? 250, right? Half of them. So if I flip a coin 500 times and I get 480 heads, that is so far away from what should happen that it's evidence that the coin's average heads is different. Something's been done to it. Somebody weighted it, something. All right, I don't know. So step C is, how far away do I have to get at least to show evidence that something's different? And then step D is, how far away did I get? Tell me how far away I've got to get, and then I'll see how far away I get. So step D is going to be very familiar. Can somebody take a minute, read through this, and summarize the sample information? So figure out what X bar is. Well, this is not too much sample information. All right, what's X bar or what's N? Is really all I need here. So what is X bar in this problem? Be really careful. What came from the sample? Anybody? What did, are you guys still with me? Has my Wi-Fi totally stopped? Is everybody still out there? What's the sample mean? Anybody? Yes, thank you, Rudy. I know what you mean, Livia. I got you. Put those together. I got you. Okay. So the sample mean is 12.45. How did I know that was the sample mean? Because they say they took a sample and they found that. Kabam. So the sample means 12.45. Now look. Isn't 12.45 more? Oh my God, Jeff. There you go. Isn't 12.45 more than 10.15? Isn't it? Yeah. So why don't we just stop there, Jeff? My God, dude. This dude went and took sample 41 and he got more than 10.15. Stop. No, that's wrong. If the mean really is 10.15, where could a sample mean be? Almost anywhere. So I take a sample and I take the mean. Is it going to be 10.15? No, it's going to be somewhere, but it's probably going to be close to 10. If 10.15 is the right mean for these coyotes, any sample I take should end up close to 10.15. That is what this step is talking about. Where does close end? So if I get a sample in here, that's not evidence that it's not 10.15. But if I get a sample way the shit up there, that's not where it should be. It should be close. Do you guys get that? That's what that step C is. If it's above 2.326, it's so far away from what would be expected that the original assumption must be wrong. The mean really isn't 10.15 for these coyotes. Okay, and N, of course, was 41. Now, before I can calculate a z-score, I need the standard deviation. What's sigma? Do I tell you what sigma is? That would really help, Jeff. I don't know. 4.27. And now you can calculate the z-score. Now look right here. I'm kind of reminding you guys. Don't worry about the p-value shit yet. We'll worry about that in a minute. We took a sample, and I'm asking about the sample mean, so I have to change the standard deviation. That's going to be just a part of what we do on this problem. So the new standard deviation, oh shit, hey, it's not horrible, is the old one divided by the square root of the sample size. Oh my God. Right? Does that feel familiar? So this problem, now, do you see how long it's taken us just to get to this step? Because I'm doing a lot of frickin' talking. So the first few problems are going to take a long time. There are 5 steps, so a normal problem will take a little bit of time. It's just the way it is. Too bad. But it's not going to take this much time. I'm explaining every damn thing I'm doing. But this should definitely feel familiar. We have to change the standard deviation. So let's see, what do we get? Oh shit, running out of time. 4.27 divided by square root of 41. Yeah, points. Ooh, it's almost evil. I like it. Point, what it was, 667. Oh, there's an extra little dot here. Just ignore it. Right? And then I can make a z-score, like I always do. Just like before. Z equals my data point, 12.45. It's always mine minus the supposed middle. We're going to assume that 10.15 is the real middle. We assume that the number from the claim is the right number, the 10.15. So minus 10.15 divided by the new standard deviation. Oh my God. 2.3 divided by 2 times 3, 6.9. It's like 3.4, is that right? Am I doing that right? I think it's going to come out to be 3.4. If you can read that right, 3.44, yeah, it's not bad. Oh, I forgot to do something up here. Oh, I forgot to finish this. Damn it, Jeff. I'm sorry. So right now, this is what I call Z star. And the only reason I do that is because I want to differentiate it from this z-score. There's a z-score, there's a z-score. Oh shit. So I call Z star my z-score, the one that I get from my sample. So see how it's, maybe I should change. Wouldn't that be neat if I change the colors just like once? So here's my stars way up here. Look at that shit. That's where we ended up, right? My z-star is 3.4 frickin' 4. It's way up here. Now watch this. This is what I didn't finish out, and of course it's remarkably important. If Z star, coming back up here, if Z star is bigger than 2326, what does that mean? All right. Where does the HO think things are? The HO thinks things are in here. So what can I say about the HO if I get out here? I can say it looks like he's wrong. So the official way we word that is, if that's greater than 2326, we reject. You're going to love this. Let me see. Do I want to be offensive? Sure. We reject the HO. which means we support the high. I really want that to make sense. Since the null hypothesis has an equal sign in it, it thinks it's in here. So of course, if I don't get in here, if I get out here, I can reject what the null said. That's evidence that the null is wrong, which means if I could say one little old dude in the coffee shop is wrong, I could say it looks like there's evidence that the other guy is right. So if I get in this, look what I call it. It's called the rejection region. Now you see why. If I get way the shit out here, it looks like whoever thinks it's actually in here, that's evidence they are wrong. I can reject what they said. I can support the other person, the one who thought it was greater than, because look how far up we got. So weird, I know. Sorry. Damn it, I want to give you guys a chance to do your own problem. All right, so coming back down here. So look, we got 3.44. Is that greater than 2326? Yes. So we can reject the null. We can support the high. Reject the null. Support. Oh, it's not supposed to be syrup, the high. Support the high. If we did not make it out here, if we made it in here, we would fail to reject the null, fail to support the high. So the whole thing is, did we find enough evidence to say the null looks wrong, the high looks right? Or did we fail to find enough evidence? Boy, that's really, whoa, geez. Reject the null, support the high. Somebody remind me, which one of those was my claim, the HO or the H1? Which one was my claim? Yeah, so therefore, I want to use this language. We have found evidence to support the claim. So let me do this. I want to, we got like 10 minutes left. We'll do this last step here in a bit, but I want you guys, let me see. Oh, shit and a half. Why did I log out of Canvas? Oh, I can pull it up here. Old man using technology. Oh, here it is. Okay, let me see if I can't do this. It's me. Here we go. Perfect. All right. Can you guys do the first couple steps on this problem? Does everybody see the problem now? It's about forward focus. Can you guys see that problem? Anybody? Can you see the forward focus problem? Yes. All right. Do the first two steps. Do these two steps, A and B. So I'll tell you, the first thing I would do is, can you see the stuff about the sample? Ignore that for now, because it's not time for the sample yet. The sample comes in on step 4 on part D. Has anyone discovered where the claim is? Which sentence has the claim? First, second, third, fourth? Anybody? Which sentence contains the claim? The first, second, third, or fourth sentence?
It's the one that says the Ford plan to see if their assembly time is the
Yes,
same.
kick ass. I'm not sure who that is out there, but thank you. See, the first thing is we just know this. The Ford Focus has an average assembly time of 38. It's known. It's not a claim. We visit a Ford plant to see if their assembly time is the same as the overall average. We want to see if they're doing worse or better. We don't care. How do you write that in Mathish? Right there. That's the claim. We're claiming we want to see if their assembly time is the same as the overall average. So how would you write that in Mathish? So you have a claim about their mean. Oh, shit. What kind of thing is this? Oh, shit. It's a freaking... Oh, that's probably better. Oh, thank God, actually, now that I think about it. It's a Word document, so I can actually type. Okay. I'm just going to write the word mean, okay? We know it's mu. Let me write mu. There we go. Mu, what? What's the claim? So this is kind of weird. Is there a directional word? Like, do you see less than, greater than, increase, decrease, has gone up, has gone down? So then it's going to be, in this case, it says is the same as. There you go, equals. Mu equals 38. So the claim, we're going to go see if their assembly time, mu, is the same as, equals, the overall average, 38. That's what I mean by you've got to piece it together. I'm not going to just give it to you, right? Finally be my mean self. So where's that going to go? I sort of gave it away there. Oh, well. Where's that go? Is it going to go HO or H1? Yes, because it has an equal sign. It's that straightforward. We designed it that way because I want to always be able to look at the high to set up where my tail or tails are. What would show evidence for the high? So the hose always got to have the equal sign because that's the thing I can't ever show evidence for. So mu equals 38. So then what's the high going to be? Is that big enough for you guys? Let me see. There we go. Look at that. There we go. Ooh, geez. What's the high going to be? You could do it, Jeff. There's red. Look at you go. What's the high going to be? Yes, not equal to. Let's see. If I was more on the ball. No, that won't work, Jeff. Screw it. I don't know how to quickly put not equal to. I have to go into my freaking equation editor and all that kind of shit. Actually, I could go right here. There it is. Yay. Ha! Okay. So let me stop right there. You got to let me know right now if you can't see where we got a part of this. The claim came from the part of the situation where we had a feeling or we want to see something, want to test something. So we want to see if it's the same. Okay, that's the claim. Mu equals 38. How many tail tests will it be? Where would evidence show up? Above 38, below 38, either way, where would evidence of not equal to show up? Is this handout on Canvas? I think so. I'm pretty sure I put it up there. Let me see. I might have just put it up there this morning. Let me see. No, shit. I need to still put this up. All right, thank you, I guess. Yeah, I didn't put it over here, did I? No, okay. I got to put this up, sorry. I'll put this up on Canvas. Sorry about that. But you can all see it right here, right? Everybody can see it? Sorry, I should have put it up there. If only I was more prepared. Oh, fudge. All right. Will it be a one or a two tail test? Has anyone told me? Yes, two tails. Yeah, I'll put it up there. So it's definitely going to be two tails because how can I show that something doesn't equal 38? Either I can show a sample that's more than 38 or less than 38. So therefore, I can't draw on here, can I? I don't know how to draw. It will be a two tail test. That's going to suck if I can't draw. Damn it. It'll be all right, Jeff. Will it? All right. Let's do one more step here. Do we use ZT or nothing? So why can I do something? Can anybody see why I'm allowed to do something? Yes. Where'd it go? Oh, I can't even see it. Yeah, n is 71, which is greater than 30. Check, right? You don't have to be all capitalized. Come on. There you go. And then how do I know between Z and T which one I could use? Which one do I get to use in this case? Standard deviation. Yeah. Which one do I know? I know the population standard deviation. Therefore, I can use Z. Z-score sigma is known. Gather. So we invented t-scores for when we don't know sigma. So when I know sigma, I don't need t-scores. It's that simple. And some of you guys are like, I don't think simple means what you think it means, Jeff. All right, I understand. I'm sorry. Let's see if we can't sneak one more problem in, even though I can't draw. How do I draw on, I'm sure there's a way to draw in Word, but don't try to teach me right now. Let me just do a line. So imagine above this is my normal distribution. So in the middle is 38. We're going to assume it is 38. And we said it, I didn't write it up here, but it's two tails, right? It's definitely a two-tailed test. You could do it, Jeff. Okay, like it's not a one-tailed test. Get out of there. Just die. All right. So it's a two-tailed test. So I want to be on either side of 38. Alpha's 0.0. Let me see if you guys, this is the last thing we'll do. Alpha's 0.05. I can use Z-scores, right? And it's a two-tail test. So two-tail, 0.05. Am I pointing the right thing? I can't see. Yeah, two tails, 0.05. So I'm in that middle column. And if I stop, I get a t-score. So I don't stop. I go all the way to the bottom and I get 1.96. Right? So I get negative. Well, let me put it on here. Arrgh. Negative 1.96. Oh my God. And then positive 1.96. Okay, Jeff. God, this is so freakadelic. Right, so that's going to be anything outside of there is going to be my rejection region. So if my Z star is greater than 1.96 or less than negative 196, because again, the null hypothesis thinks it's somewhere in here. So if I get out here, that would be evidence that the null is wrong. That would be evidence that the alternate is right. Not proof, but evidence. If Z star is greater than that or less than that, we can reject the null. Sapati, support H1. Or let's do H1 there. All right, I think that might be enough for today. Woo! Now, let me say a couple things about chapter 9, if you haven't noticed this yet. 9.1, 9.2, 9.3, 9.4. They break up the steps of a hypothesis test into chunks. 9.5 is where the problems kind of start. The full 5 steps start in section 9.5. 9-1, 9-2, 9-3, 9-4 get to the idea and the concepts behind each step. 9-5 is the first place you'll do complete hypothesis tests, all 5 steps. Is everybody semi with me? So what I think I need to do to make this work a little better, I got to put that up. There's another side to the sheet back here. And I need to probably make a video of me just going through one of these problems straight up. Yeah, so that's getting harder and harder to do. So, but let me do that. Come on, holy shit, so many notes. Maybe I should look at them someday. We'll see. All right. So I got to post the hypothesis practice sheet, and I'll make a video going over a hypothesis example. There are a couple details in 9-1 through 9-4 that we have to go back and kind of do. Plus, we still have to figure out how to answer this what is your conclusion step. We haven't done that yet. But I don't want to throw a bunch of shit at you. So I really want you to realize 1, 2, 3, 4 goes over the 5 steps. Section 9-5 is the first place you do full hypothesis tests. So by doing this, we are doing the whole chapter. So that's why it seems like a lot, because it is. It's a lot. I think it's enough. Anybody have questions they need to hang out for, anything? I have my standard 9 o'clock meeting. Oh yeah, I need to do that too. I've got a video I made for that practice test 3 that is up on Canvas. I just got to post it on the YouTubes. Practice test 3 video to the YouTubes on the internets. Okay. I did not see that we had an assignment due. My Canvas has not been giving me notifications. Oh, yeah, you could do that. So if you didn't do that T-score practice, please go ahead and do it still. That'd be great. It's good practice. You could turn it in. I'll see when you turn it in. I can give you some pointers. There is a place in Canvas where you can fiddle with your settings to turn on notifications. Let me see if I can't see it. No. I hate that. All right. Student view. I don't remember now. Shit. Yeah, if you go to account and hit notifications, I think that should work. Damn it. Where is it that you guys can do this shit? Settings? I knew this a minute ago and now I forgot. So if you're not getting notifications from Canvas when I like post new stuff, there is a place in Canvas that you can change that so you do get notifications. And I thought for sure it would be if you click account. Do you guys see notifications in Canvas? That should be where you can control notifications that you can get. Is that all right? Okay, so make sure you get notifications so you know when I post a new thing. Quiz on Wednesday is only on chapter 8, yes. Quiz on Wednesday is only on chapter 8. I will put the formulas on the quiz. Anything else, guys? So everybody else is hanging out so they don't miss anything. All right, I'm gonna shut things down if I don't see any more questions.
I have one.
Oh, what's up?
Just about the T-score practice, the 8.2. Are you gonna post that video too? Or you already did?
Sorry, do it again.
The T-score practice.
T-score
8.2.
8.2.
So we had to figure out the depth of freedom.
Degrees of freedom, sure. What about it?
If you're gonna post a video for it.
So that T-score practice handout where it had the two sides, is that what you're talking
Yeah.
about?
Yeah, there was it asking us for identify if they were a Z-score, T-score, or nothing.
Oh, shit. I haven't done that yet. Dang it.
And
Jeff.
I think the third question gives us like grades, and then we gotta like place
Do it
them.
in the one var stats?
Yeah.
We didn't do that together? Shit, I thought we did that.
I don't remember doing those together.
All right.
Or did we?
Let me see. So I'll make a note. Let me double
If
check
we
on that.
did, I'm sorry.
Score practice sheet video. All right. What am I remembering? I thought for sure. Oh, we did a problem. That's right. I wrote it up on there. We did it together with the one var stat stuff.
Okay.
A2 you posted on the YouTubes, on the internets. I thought I did.
Okay, so I'll double check because I didn't see this video.
Let me see if that's true. YouTube's on internets. Oh, yeah.
Oh, okay, it's there.
Solutions to the T-scores practice sheet. Yeah, it's up there on the YouTube.
Sorry. Okay, I'll double check.
All right. Thank you, though. Yeah, you never know. You got to keep me
Okay.
straight here. All right, guys. I'll see you guys next time. Hopefully everybody's actually here because I'm about to close things down. Bye.